Hello and welcome to the Srijan Wednesday webinars. If you are joining us for the first time, this is a community initiative by Srijan Technologies where you can tune into some great sessions on topics ranging from front-end technologies, UI UX, mobile apps, to media, entrepreneurship, community building, and digital marketing. In today's webinar, we take a look at some JavaScript code that you know isn't optimal but don't know how to fix. These are called CodeSmells, and our speaker is going to take us through the tips and tricks of how to identify such suboptimal code and how to get rid of it. Our speaker for the day is Elijah Manor, who works as a senior software developer at LeanKit. He is also a Microsoft MVP and Pluralsight author. Before we get started with the session, I would like to request all participants to please type in any questions that you have during the session, and we'll take them up in the last 15 minutes of the session. Also, please don't forget to take the conversation live on Twitter using our hashtag SrijanWW. You can share your thoughts by tagging us and the speaker with our handles @Srijan and @Elijah Manor. So, without taking up any more time, let's get started. Elijah, over to you.
Thank you. It's an honor to be here. Thank you for your time. So like she said, we're going to talk about JavaScript. And so these are things that actually work, but there's something wrong with it. And I've had some talks in the past about JavaScript that doesn't work, and we try to fix it. But this one is actually things that do work, but we want to make it look a little bit nicer. Since she already gave me an intro, I'll just kind of browse through that. So the first thing we want to talk about, and hopefully most of the audience understands about this, there's an idea in JavaScript about linting your code. There's these style checkers that kind of look through your code to find common problems. It's been around forever. Douglas Crockford, the person in the background, created eslint many years ago. Kind of the joke is, to lint or not to lint, that is the question. Whether 'tis nobler in the mind to suffer the slings and arrows of outrageous bugs, or to take arms against JavaScript's bad parts, and by opposing in them. So I'm pretty much butchering our history there. But Descartes also said, I lint, therefore I am. So it's really important that you lint your code because it really does protect against the bad parts of JavaScript. Now, what we're not going to talk about are the things that really are easy to lint that have been around for many years, because you've probably seen talks about that. What we're going to talk about are, just to begin with, are some things that are easy to lint, but some newer rules you might not be aware of that JSLint, JSHint, and eslint support. Then we'll talk about some rules, things that are easy to lint, but there are no rules. So some things that are kind of smelly code that you probably should fix, but wouldn't it be great if there was a tool, but there's not. And the last thing we're going to talk about are some things that are really subjective. They're still kind of code smells. It's something you want to eventually refactor, but it's really hard to actually make a program to identify those. And so that's kind of the agenda where we're going to go. Each one I try to give this clever name. I think they're clever. You might not think they're clever, but this one's called the convoluted code smell. Some pigs in the background. Each point will have these circles to show if it's easy to lint or not, meaning is there a tool to identify this smell? One is there a rule or not? And another one, the code that you're looking at, is it more junior dev? Is it a mid-level developer code, or is it like senior level code? Just so if you start to feel uncomfortable, you're like, oh, that's senior level. Maybe I could look at it later. So just kind of, and then we'll tuck those here on the side as we go along. So when I was little, I didn't really know other languages like Spanish or French or whatever. But there's this thing called Pig Latin. It's just really silly language where you swap some letters around and it sounds like you're speaking another language, but you're really not. So for example, if you start with a consonant like pig, you take the P, put it at the end, and add a Y. So pig becomes igpay, trash becomes ashtray, just really strange things like that. If it starts with a vowel, then you don't move the beginning letter. You just add way. So egg would be eggway. We keep the E there. So I thought it would be fun, and actually I did a series of blog posts about making a Pig Latin converter with JavaScript. And this was many years ago, and in the blog post I was like, this is not the greatest code. Eventually we'll refactor it. And I went back and looked at it, and I'm like, wow, this is really awful code. It's not just bad. It's just I don't expect you to read it or even understand it, but if you could just look at it, it's like, wow, that's really complicated. And if there's anything that, if there's a bug in here, good luck trying to find it. You almost have to make sense of the whole program just to figure out what's going on. So you can kind of feel that it smells, but why does it smell? Well, in that particular case, there are lots of reasons. One, there are way too many statements in one particular function. It's just too much for your brain to get kind of your head around. Also, it was too deep. I don't know if you noticed, but there's like multiple levels of nesting, like an if instead of a when instead of a for. It gets really complicated much too quick. And so we mentioned this word complexity, and that sounds a very arbitrary statement. However, there is actually an algorithm to detect complexity. Back in 1976, Thomas McCabe came up with this thing, cyclomatic complexity. It basically looks through a function or a method and looks for all the different ways, all the branch logic, basically. And thankfully, there's some tools that can leverage this algorithm. So JSHint, which has been around for a while, which is a linter, it supports a max number of statements, max depth, so how deep the logic goes, and how complex. So it uses that complexity score. Now, eslint, which is what I recommend these days. It's a newer linter. It has all the things of JSHint and JSLint, but much more. It also supports these rules as well. You could tell it a threshold of how many statements you want to be your maximum, how deep you want to go, and your complexity. So what we could do is we could add these rules to our Pig Latin code, and we'll start to get some errors saying, oh, wow, this is way too complex. It has a score of 7. Or it has way too many statements. Your max is 15, but there were 16. It was way too deep. If we look back here, you'll notice, oops, let's refresh this. We have 1 level here, 2 levels, 3 levels, 4 levels, 5 levels. It just gets really deep really quickly. And so that's what I mean by depth. So what we could do, there are actually other rules as well. There's max length, so how long the line is, which typically I don't care about so much. Max number of parameters, how many things you pass into a function. You don't want that to get too complex too quickly. And eslint also has a max nested callback. So if you've ever done async code and you have callbacks, it can get nested really deeply, and that becomes really hard to deal with. And so you could actually have a threshold for that as well. So what do? When you have really complex code, you need to refactor it. But before you do that, you probably need some unit tests, because if you're going to refactor your code, you probably need to make sure you're not breaking it in the process. So here I have some JavaScript unit tests. I don't expect you to read them, but pretty much I'm just verifying that the converter is doing what it needs to do. So once I do refactor the code, I can make sure I didn't break anything. So here's a quick kind of pass at a possible refactor of the code. I used ES6, so if you're not familiar with that, don't worry. But essentially, I broke it up into nice little chunk individual methods, like have a isValid function, starts with val function. So I really broke up the logic into the bite-sized pieces. And so my main kind of driver is this English to Pig Latin, which I'm calling these helper methods to work with. And I'm using index of and reduce and things like that, some more advanced techniques. So again, I don't expect you to understand all of it, but the main idea is I had some really complex code, and I've made it better. So I went from a max statement of 16 down to 6 lines per function. My depth went from 5 to 2, so that's much easier to get your head around. My complexity went from 7. Now some things went up. My max length went up because I was just trying to be a little tricky with one-liners. Params went up, and that's 2 is not bad. And my callbacks went up, but that's not bad either. It was just 1. But the idea is you should somehow bake these into your IDE or your build system if you use Grunt or Gulp or npm scripts or whatever editor you use, Visual Studio, VS Code, Sublime, or Atom. You should bake these into your development environment. All right, the next one we're going to call the copy-paste code smell. Now this one's pretty obvious just by the name of it. So here's kind of a scenario, and it's very contrived. Let's say your boss says, "Hey, I need you to make a whole bunch of squares that are random colors, and inside each box it has the number. So 0, 1, 2, 3, 4, 5. So let's say you wrote some code like this. Let's decide you didn't want to use jQuery for some reason, and so you use query selector all. You want to do for each on the result of boxes, but it's not technically an array, so you have to do this weird trick that you probably found on Stack Overflow or something, because it's a node list, so you have to do this crazy hack where you use an empty array, call for each, and pass in boxes as this parameter of call, so you can loop over it. And again, if you don't understand it, that's fine. But you have to do some weird tricks if you're not going to use jQuery. So we also found this little script in Stack Overflow to make a random color. So we do some bit shifting, some really crazy things. But we got it to work. All's good and said and done. Even if you don't understand it, that's fine. But let's say your boss comes to you and says, well, now we have circles, and the random colors are the inside of the boxes, or inside of the circles. We still have to add the indexes. So maybe you didn't do this, but maybe your friend did. Your friend's like, oh, you wrote this code the other day that did this. I'm going to copy and paste that into my code, my Circle.js code. It looks very similar, and pretty much why you copied it. But a couple things are slightly different. You're changing the inner text, changing the style of the element, not the background. But all the, the crazy Stack Overflow code is the same. Now, obviously, this is a problem. I've done it in the past. I've copy-pasted code. But if you keep doing this, your code base is going to get sloppier and sloppier. If you found a bug in one of these, good luck trying to find all the use cases to fix them. So obviously it smells because we copied and pasted code. Thankfully, there is some tooling to help detect this. There are two tools I'm going to share with you. One's called JS Inspect. So it's a JavaScript inspector. You run it against your code base, and it will detect, depending on a certain threshold of how exact it needs to compare. So what I did is I took two of those algorithms, stuck them in two files in different locations. I had code before and after, and sure enough, it found that they were similar enough that maybe you should refactor that out into a common method. There's another tool called JS-CPD, and this one's probably quite a bit cooler because it could detect copy-paste errors across JavaScript and C#, Ruby, CSS, HTML, lots of other languages. And you can actually control how specific it's comparing, because you don't want to fine-tune it too narrow, because then it'll think everything is a copy-paste error. So you kind of want to play with that threshold. So I ran these tools against a code base I was working on, and I was actually a little concerned. I'm like, am I going to have problems here? Is it going to find a lot of issues? Thankfully, it didn't find many. The ones it did find, I was pretty much okay with what it found. It was kind of my transformers, the data I get back from Ajax. We kind of massage it, we transform it to look like something else that our application expects. And there was a little repetition, but I was okay with that layer having a little repetition. So maybe integrate this with your build, your Gulp build, your Grunt build, or your npm scripts, or whatever you use, or even just do it on the command line to figure out possible areas you could refactor. So obviously, the next step is refactor. Hopefully, you have some tests. So the first step we could do is pull out the random color that we grabbed from Stack Overflow. So now we have this method called random color that we could call in both cases and reuse that functionality instead of duplicating it. We could go a little further. We could actually pull out that crazy query selector all with the for each. We'll use something slightly different. Well, you call it double $sign because it's twice as good as jQuery. Just joking, not really. But it's doing something very similar where it's converting the node list into array. Again, if this doesn't make sense to you, that's okay, but that's essentially what I'm doing here. I'm converting it to an array so that I could call for each onto it. We can get even more crazy. I'm going to kind of brush over this. But we can keep extracting until we feel comfortable that we've done a good job. So the tools for this particular code smell are JS Inspect and JS-CPD. And all the code you can find later in these slides. So this next one's semi-controversial. Some people might think this is a good smell. Some people might think it's fine. Definitely worth talking about. But something I consider a smell is a switch statement. And you could tell that by the name of the smell. but they're very common, and many languages have them, and why is it bad? So we'll talk about it, and maybe you'll figure out if you agree with me or not. So here's a common switch statement. We have a getArea method where we pass in a type, so like triangle, square, rectangle, or whatever, and we give it some options. So a triangle has a width and height, square has a width, etc. It comes into the getArea, we switch on the type. So if it's a triangle, then we take the width and height, multiply it by 0.5. Square, we just do a power of 2, etc. It's not really important, the logic, but we're just using the switch. Now, the problem is we're violating the open-closed principle. And if that's new to you, it's one of the Uncle Bob's solid principles, where he describes that a function or a class or module should be open to be extended, but you shouldn't actually be changing the code inside of it. And that sounds a little high level and like, what does that even mean? It sounds great, but looking at an example will help us a little bit. So if we added a new shape, if we wanted to add a circle type, we would actually have to go into the getArea function that currently worked, and we have to modify and actually add code to something that already existed. And we could actually, this is kind of dangerous because we could actually accidentally break an existing function called getArea, which is not a good idea. So one way to get around this, anytime you see a switch statement, usually you could refactor it with a design pattern called strategy. This is one of the Gang of Four design patterns. And if you haven't studied design patterns, those are great to study. So we're going to solve it with a strategy pattern. And what we're going to do is each of our types, we're going to create an IFE. And if you haven't seen an IFE before, it's kind of a way to manage your code before modules existed. But what we're going to do is we're going to create a triangle constructor function, and we're going to give it a getArea method. And we're going to register each of these types onto the shapes object. So there'll be a shapes.triangle, a shapes.square, etc. And then what we'll do in our getArea, so we'll have tons of these throughout our, we'll have one for triangle and one for circle and things like that. What we'll do for our getArea, we'll still pass in the type. So our API looks just the same, triangle, square, rectangle, bogus. But what we'll do is when we come in, we'll look off the window and see if that constructor function exists. So if it's triangle, it'll look, does shapes have a triangle constructor function? If it does, if it exists and it's a function, meaning we can new it up, then we'll new it up and call the getArea, because all of them share the same API of a getArea method. And if it can't find it, then it will throw an exception, and we're good. So the beauty of this is if we wanted to add a circle, we don't have to change any existing code. All we do is create a new file called circle.js and write this code. We do not change anything that existed previously. So what we're doing here is we're basically adding a circle constructor function onto the shapes that's kind of global at this point. It has a getArea method, which the API expects. Now we can add other stuff if we want, like get circumference. It won't matter. We're just containing our functionality in one location. And now, magically, we support a new type, and we extended it, but we didn't modify something that already existed. So does the code have other smells? And yes, there are magic strings in our code, which typically is not a good idea. So, for example, this is a magic string. If I'm a horrible speller, I spell things wrong all the time, and so relying on my spelling of triangle is probably not the greatest idea. So some ways to get around this is just create like an object type. So I have a shape type, the key of triangle that matches to like a string of triangle. And then when I call it, I use my object type, and when I'm doing the case statement, I use my object type, or if I'm refactoring it to the strategy pattern. We can go one step further. With ES6, there's the idea of const and symbols. So const is, if you're familiar with other languages, it's a way that you can't change, the pointer of the memory location. So, for example, I can't rename shape to something else. However, I can change triangle, and that's kind of a debate these days. But what we can introduce is a symbol. So a symbol is something very unique. It's almost like an enum if you've used enums before. But there's no way to kind of fake that. And so if I use these symbols, then I've really specified, there's only one way I can interact with this particular function, which is really, really good. So you don't want to have typos. It'll immediately just fail, and you'll know it instead of it just not working. Like, why is this working? I can't understand. So tooling, unfortunately, there's not tooling to find this particular smell. However, I did write a whole bunch of custom eslint rules to find many of these smells. One of them is basically no switch statement, which might be a little too severe because maybe you have already a lot of switch statements in your code already, or maybe your friend has written some and you can't refactor it just yet. So there's a couple other rules like no complex switch case. So if you do feel like you need switch cases, the cases should be very simple, like almost one-liners. The danger is when the code inside each case statement starts to get bloated. You start adding other lines of code, other statements, and then it becomes a little unruly. Now, definitely there are edge cases. Per file, you could turn off these rules. So on the top of your file, you could say eslint no switch 0, meaning ignore that error. Or eslint has this idea of these comments, so you could disable certain rules and then you could re-enable them. You can be more specific, like I want to disable only the no switch rule. I want to re-enable that rule. And you can even just disable things on one line. So if you want to continue to learn about design patterns, here's a free link to a PDF that you could look at. Definitely learn about ES6 if you don't know about it already. There's some really great things about it to learn. All right, so now let's switch to the this abyss smell. This one catches a lot of people, even mid-level developers and some advanced developers still have problems with this. So here's some code. We have a constructor function called person, and a person has teeth, an array of teeth. This person apparently has 3 teeth, but each one has a Boolean if that tooth is clean or not. So by default, all these teeth are dirty. And we have a brush method off the constructor function that basically loops over all the teeth and cleans them. And then you could call out clean, actually to flip the bit. So we're going to new up a person, brush his teeth, and then just log his teeth. So the smell in this code, and you might spot it, some people it's a little somewhat controversial, is the idea of a variable called thatself or selfie. If we go back and look, you'll notice they saved the this implicit parameter as that, so that inside of this loop, they could call clean, and they're referring to the clean method. But if they're inside of the for each, the this is not is object anymore. So they have to save it off, and it's a common problem that a lot of people have. And it smells just because it's that pattern of using that or self. Some people call it self or that. And my joke is you call it selfie, but it's not that. Well, it does kind of stink, and mainly because it reveals that the developer might not realize there's other ways to solve this problem. And so it's kind of an exercise in kind of learning. So there are many other ways to solve this problem without saving off a variable as that or this. And here's one of them. For example, there's the bind method. Now, this is not the method off of jQuery that you might be used to. Each function has this extra method called bind. And what you could do is you could tell it, hey function, whenever you run, whenever that is, I want you to bind this parameter inside of it to be something else. And then what I'm essentially doing here is I'm making sure that the this inside of the for each is the same as the this outside of it. So I'm kind of trying to bleed in the this from the outside and push it to the inside. Which saves us from having to do that var that equals this. So another alternative is the for each method actually takes a second parameter, and not many people realize this. The second parameter of the for each method, you actually tell the inside method what you want this implicit parameter to be. So in this case, I want the inside this to be whatever the this was on the outside. Now this looks really crazy because I have this here and this here and this here, but you start to get used to it. Strangely enough. Another way to solve this is ES6, ECMAScript 2015, has the fat arrow, and you might have seen this before. But essentially what it does is it doesn't change the definition of what this is. It just passes it through. And so the this inside happens to be the same as the outside. So you don't have to do anything special. As long as you use this fat arrow, they share the same this context, which is nice. Another thing you could have done is, this is functional programming. We could have just told, instead of actually having another wrapper function, we could have just said, hey, loop over all your teeth, and by the way, just call clean. You know, each time you loop through, call clean, and it passes that parameter through, and it actually cleans all the teeth, which is nice. Now, a problem you could have is if clean uses the this implicit parameter, you'll need to do one extra step where you bind it and pass this in. But again, this is senior level code, so if it doesn't, don't worry about it. There's many other ways to solve it. So again, no real tooling for this, other than the one that I made, but there are some interesting existing tools. The one I really like is no extra bind, meaning if you don't need this implicit parameter inside the function that you're going to loop over, there's no reason to bind it in the first place. So there's no reason to do extra work if you don't actually need it. So definitely look that one up. It's pretty cool. I made this one basically that you can't assign this to something else. That might be a little overkill, but it was kind of fun to make. So the next one is called crisp concatenation smell. Now, I've written this code in the past where basically I'm concatenating tons of strings together, and it's really hard to read. Where here I'm trying to build up some markup that I want to actually create with jQuery, and it's just really hard to read because I have to like really be careful about my double quotes and my single quotes, and sometimes I have to escape my quotes, and getting the whole idea of what I'm trying to build is kind of hard because I have all these pluses and quotes, and it's just really smelly. It's smelly because of string concat. It's a cat that's a convict, but it's a really bad joke. But string concatenation is the smell. There are many alternatives to this. One is to use just a teeny little template library. There's a tweet-sized one by Thomas Fuchs, where essentially here it is in its full glory. The way you use it is you just call t, you pass some string, you use curly braces, and then second parameter you pass in an object that has the keys. So it has an ID, an href, and a text, and they just match up to whatever's in the curly braces. And that just works just fine. And I've used this in really small projects that I wanted my code a little bit cleaner, but I didn't want to pull in like a huge templating library like underscore or Lodash or something like that, or handlebars. Another way to solve this problem is if you can use ES6, then there's actually something called template strings. Now these use the backticks. Now you might not have seen these before, but these are special. It means this is a template string. And you do use a special syntax, a $sign and curly brace. And what that will do is it'll look for memory inside of its current scope and just replace that. So I have href here, so it'll just swap that out there. I have ID as a parameter, ID as a parameter, and so it just swaps it out here, and I have text. Now a danger of this is there is a danger of using this with markup, because it could lead to cross-site scripting attacks. And we'll take a look at that in a second. But there is, with template strings, you can use multi-line, which is really great. So I could start the tick here, end the tick here, and actually I could put carriage returns, and it can actually look nice. I don't have to do it on one whole line, which is really nice. Or, split them up with concatenations like you might have seen in the past. Like I said, there is the idea of cross-site scripting attacks. So there's the idea of tagged template strings. You still use the ticks, just like you did before, but you can actually prepend it with a special function that all your code goes through, and you can kind of sanitize and clean up the markup and replace it, protect against cross-site scripting, essentially. Here's a very naive example of what the sanitize HTML method would look like. You'd obviously want something much more rich. I'm not really going to go into detail of this because it gets to some advanced topics, but just keep in mind, be careful with tagged, with template strings, especially if you're generating markup. You'll probably want to sanitize them. Now, for something more rich and involved, you might need the template method in Lodash underscore, or possibly look at Angular or React or Ember. But for simple things, most of these alternatives work just fine. There are no tools to detect these. I did create one called no complex string, but again, it's a little overboard. But most of these solutions will help resolve those. Now, although jQuery is not like the hot topic that you see at all the conferences, still tons of people use it. So I wanted to mention a piece of code that is kind of smelly. I've written a lot of jQuery in my day, and I've written code like this before too, where here I'm grabbing a component, I'm looking for a button underneath it, I'll add a class to it, I'll wire up an event handler, I'll call end, which pops me back up to the component level, and then I'll add some other event handlers, mouse in or mouse leave, and I'll eventually add a class to the component level. And I'm also waiting for DOM ready. Now, it smells for several reasons. One is extreme chaining. All of this is one long statement. That is problematic because jQuery has this thing where if it ever encounters a problem, it usually just ignores it. So if you try to select something and it couldn't find anything, it'll just keep going. It'll let you pretend to add event listeners. It'll pretend to add classes. It'll just silently fail. And so it's kind of problematic to have one super long statement. Also, it's just really confusing. So when I refactor this, I'm not just going to split it out into multiple statements, because that would be a way to refactor it. I mainly wanted to rethink about how we solve the problem. So before, we were waiting for DOM ready for all code to run. But there's no reason to wait till that far in the process to actually run our code. We can actually delegate several of our event handlers way before DOM ready even happens. So for the mouse enter and mouse leave, we could delegate to the document, tell it to listen for those events on the component. If it ever happens, I'll just toggle that particular class. I can listen for clicks on the component button off the document. Now, these are just wiring things up. They're not doing anything yet. They're just listening for things that will happen later on. The only thing that I really need to wait for DOM ready is to actually add a class to a button that exists on the page. So I do have to wait for that. So it's really just thinking outside the box. And they both work just the same. If I hover over either solution, the old solution, the new solution, they still work the same. They still respond to event handlers just the same. Whereas these are bound directly to the elements, and these are actually delegated to the document. So some tooling. I did create a no complex chaining rule for eslint. You're welcome to try that out if you want. This next one I call the repeat reassign smell. Now, a friend of mine at work, I had given this talk, and so he had the idea of CodeSmells on his mind, and so he came up to me and he's like, I'm doing a review of someone else's code, and I see something like this. It feels redundant and smelly, but I'm not sure quite how to refactor it. So here I'm passing in some data into a function, returning the massage data, passing it back into another one, getting it out, passing that back into another one, getting it out, passing that data into another one, getting it out. So it's kind of just flowing through a series of functions. So it smells because it's a bit repetitive. There's something about it that just feels like it needs to be better. So we sat down and walked through several different solutions. Some are not good at all, and some are better than others. And this was one of the poor choices. But I said essentially what we're doing is we're passing data into one. The output of that one is the input of the other. The output of that one is the input of the other. The output of that one is finally gives me the solution. But we have this really crazy nesting, which typically you want to avoid because it's very brittle. Like if I wanted to add another one, I'd have to nest it even more. So another solution is like, well, we could put all the functions in an array and loop over them. So that's what we did. We had an array of functions. We looped over the functions. Each time we passed the data in, we saved it out. We got to the next one, passed it in, saved it out. This one we didn't like as well. We definitely liked it better than the first one, but we have this global data, so that's passed in, and didn't feel quite good about that. Although that's what it was doing before. Then we tried reduce. So reduce is another way. Reduce still loops over things, but it kind of builds things up. So what you do with a reduce is you hand it a function, just like we did before, but then you pass it additional information to get started. So here's the the data that we want to get started with. And this data gets passed in as this memo. This memo, it builds up over time and is passed to each iteration that it loops through. So as a memo, we'll pass it in here. We'll return the new value, which will then be the memo for the next loop. And then so we're kind of constraining our information that we're building up only to inside this reduce. And so I really like that. So we pass in one thing, but we get out a brand new thing. Everything else is kind of internal to the reduce method, and I like that better than the for each. The last one we did, underscore and Lodash have this method called flow. And essentially what you do is you pass it all the functions that you want as parameters, and then you give it the data that you want to pass through each one. So data gets passed into the first one, whatever's returned gets passed into the next one. So it's essentially what we wanted. There just happens to be a method for it. So it was more of an exercise in just thinking about a problem in different ways, which is always kind of helpful because sometimes we just use the same hammer for the nail when maybe a different tool was necessary for that. So some things to look up if you weren't familiar with for each or reduce or flow, definitely look into those. Reduce is very powerful if you've not used it before. Here's another one. I call this the inappropriate intelligence smell. It's kind of a mouthful, but essentially what we're doing in this particular code snippet, think of like Amazon. We have a shopping cart and we have these products, and we want to add a product to the shopping cart. So in this particular case, my shopping cart has an add item method, and if I add an item, then it will add it to its internal kind of array. I have a product and it has an add to cart, and if I say add to cart, then it'll add to the shopping cart. So what we're going to do is create a new shopping cart, create a new product. We'll tell the socks to add itself to the cart, and now the shopping cart should have some items. So the code's not too complex, and we're trying to make the code kind of independent. But the problem that we have is it's tightly coupled. I don't know if you noticed too much, but there's this global shopping cart that the product knew about. It really shouldn't have known about it. It's relying on something that was global that it should not have been. So if you actually try to reuse some of these parts, you start to realize, they're kind of really tightly coupled. So there's some ways to get around that coupling. So line 8 is where the coupling happens. So we can use dependency injection. It's one way to get around tightly coupled code. Or we can use a message broker. So we'll look at both of these solutions. So what we could do, when we knew up the socks, the product, we could actually pass our shopping cart as a parameter to our constructor function. So here we know it's socks, but we also are telling it, here's the shopping cart to use. It saves that off, and so now when it adds to a cart, it uses an internal shopping cart that it saved off previously. The nice thing about this is if you are doing unit testing, you could possibly pass in a dummy shopping cart, like if you don't want to use the real one. Or if maybe you're doing split testing and you want to pass in a super awesome shopping cart, then now the socks uses the super awesome version. So you're not tightly coupled to one implementation. It's much more flexible on what you can do. Now there's also a message broker. So the idea of that is you have this external kind of listener and publisher. I'm using a library called Postal that my friend Jim Coward made. Essentially what I'm doing is the shopping cart is listening for a shopping cart add event. If it ever hears that event happen, it'll add to itself. The product, instead of directly talking to the shopping cart, the product will publish this message saying, I'm adding something to the shopping cart, and by the way, here it is. So they don't actually have hard references to each other. They just are listening and publishing messages that are similar. And so they have a very a loose coupling, which is nice. It's message-based architecture. This would be even better if I passed in the broker, the channel to the product in the shopping cart. I'll leave that to your imagination. So tooling, definitely use Postal. It's a great message broker if you haven't used it already. It has tons of other features which are really nice. I call this next one the incessant interaction smell. Let's say we're creating an autocomplete wizard or something where maybe you're on Amazon and you're looking for a gift because Amazon Prime was yesterday, and you're looking for a gift and you want it to start auto-completing. So I'm listening for an input event, and I'm going to maybe do an AJAX call to my backend, and I want to show some code to the user. Now, the previous code that I showed is very naive. Every time I event, which is every keystroke, it's going to maybe make an AJAX call. Now, that's going to be way too chatty. So for each character I make, the autocomplete callback is going to be called, even for deletes and for adds. So for each of these keystrokes, imagine we're making an AJAX call to our backend. Well, our backend friends will not like us. So there are several ways to get around this. One, we could possibly throttle the event. So underscore and low dash have this throttle event. You just wrap it around your functionality, and I say only call the event once every half second. So if I do tons of keystrokes, backstrokes, it's only calling at most one every half second, which is great. But if you think about it, I wasn't even done taking a breath yet. I probably didn't want the AJAX call to be called that many times. Another solution is called the bounce, and it's I wouldn't have even thought of that term. The first time I learned about it, I'm like, oh, that's great, that's a handy tool, but I never would have thought to use that word to solve it. But essentially what this means, and I'm just going to replace the word throttle with the bounce, and I'm still going to use the same interval. What this means, it's easier shown than explained. I'm going to type a bunch of characters, backspace, backspace, type some more, type backspace, backspace, take a breath for half a second, and then it makes the AJAX call. So this allows the user to actually get their thoughts out of what they're actually trying to do, and until they briefly waited for at least half a second, and then it triggers the event. So this is probably a better solution for like an autocomplete, and you could change these thresholds, obviously. But I found the bounce works pretty well for scenarios like this. Or if you want to do autosave, wait till they stop typing for like 5 seconds before you start saving things. So some tools here. Lodash is great. Throttle, the bounce. Tons of other methods in Lodash. I encourage you to look at it. All right, so this one is a little tricky. This is called the anonymous algorithm smell. And the solution that I just told you was great is actually, there can be a smell to it. So it's a little funny how it works that way. But this is the exact code I just showed you, and I'm saying it's smelly. Now, why am I saying it's smelly? Well, there's an anonymous function there. There are some really good reasons to actually name your functions instead of having anonymous functions. One is stack traces. If you ever start doing debugging your code, stack traces become way easier because there's actually a name to it. Dereferencing, we'll talk about that what means, and code reuse. So for example, if we were to do a stack trace, a profile in our code, and we have this anonymous function here, good luck trying to figure out which one it was. Would it be this anonymous function? Would it be this anonymous function? Would it be this anonymous function? You have to start splunking into all of them just to try to find the code that's inside of here. Now, just so you know, it happened to be the first one. But I had to open it up to see the log that's being called, which is probably not optimal. Now, give it a name, which is no longer anonymous. But if I just give it a name of matches, when I run my profile, then it shows up as matches. I'm like, oh, that's great. That's exactly what I want to look for, and I don't have to go through all the anonymous ones trying to find the thing that I needed. It's also good with stack traces, so if you try to figure out what function called you, that's a different view. If you name it, it makes it a lot easier. Now, there's a problem when we start using the bounce or throttle. Even if we named our anonymous function, underscore and low dash call their method as you, which is not very helpful. But if you know that, then it is helpful. But one way to get around that is if you change this tree drop-down to bottom up, then it inverts kind of the call structure and puts the inside method on top. So now it bubbles up the matches to the top and puts the U underneath. So still, if you name your functions, it still is a lot easier to look at profiles, stack traces, and things like that. Another thing, if you name your functions, is you can dereference things. So if you've ever needed a click handler that only clicks once, like let's say you wired up a add event listener with click, but as soon as it clicked, you wanted to remove the click handler right away, then what you could do is if you give it a name, like handler, then immediately once you respond to it, you could say remove event listener, give it the event type, and pass the same handler that you happen to be in. And so what that does is I could click one time, but now if I click again, it doesn't work anymore because I told it to remove itself. Now this could also be helpful if you do event-based architecture, like if you want to subscribe to an event but only one time, then give it a name, and then once you're inside of it, then you would unsubscribe to it. So it can be very helpful. And I needed to use that pattern, not a lot, but when I do need it, it's really handy. Another one is just code reuse. Like if you have a particular piece of code that you want to use over and over again, save it off, give it a name, and now I could use it over and over again. With anonymous functions, you would have to kind of repeat that over and over again. So the main resources here is just understand your dev tools, realize that naming things can be helpful. So we're kind of wrapping up now, but I wanted to mention that there are lots of other ESLint rules that you could pull. So if you're doing a React code, if anyone's writing React code, the Facebook library, then someone has actually made a whole bunch of rules just for React about best practices, things you should be doing, things you should not be doing, and it's a very active repository. And so if you're using ESLint, you just pull that down, add it to your config. If you're writing Angular code, the community has written a whole bunch of custom rules just for Angular, because there's a kind of a certain way that you write Angular code that's, that the community has figured out is best practices. If you're writing Ember, again, the community has done a great job building those. Or Backbone is another MVC library. And there are tons of others. So if you're writing unit tests for Jasmine, for Mocha, if you just search npm for eslint-plugin, you'll find tons of rules. So when you get this slide deck, the cool thing about it is I wanted to save enough time for some questions, but there are several things that I skipped just for a little time to save time for questions. But there's a nice one on timing. There's a nice one on testing unconfirmed code, and there's a nice one on like two-way data binding, being a smell, and the solutions for that. So anyway, you can find me on my blog, ElijahManor.com. I'm on Twitter at ElijahManor, and here's the full slides. If you go to bit.ly/js-smells, you'll get all these plus the ones that I skipped over for lieu of questions. So if there are any questions, I'd love to host those and take a stab at answering them. Thanks for having me.
Thank you, Elijah. That was a really great session, and you handled it really well, taking us through a lot of different CodeSmells and how to get rid of them. So we already have a couple of questions here, and I would like to point out to my listeners that you skipped parts of your presentation so that you have time for questions. So I would just ask all our listeners to send in as many questions as they have so that you can answer them. So we already have a couple of questions with us right now. So the first one is thatself versus bind. You had a part about that in your presentation. So the question is bind not performance costly as it always creates a new function?
Yeah, I mean, we get into micro performances when we talk about some of those things. I have never found ever a problem with bind being the issue. Essentially, you're creating extra scope anyway with if you're saving off a variable, ones versus a slight wrapper. Either one's, yeah, you won't find any performance problems that I've ever seen doing that. And again, that's getting down to micro performance. At some point, you need to solve the problem. And many people these days use the arrow function with ES6 to solve the problem. However, it's good to know all the different ways to solve it, because sometimes you don't want the outside this in the inside. And so if you always use the fat arrow, you might be like, oh, I don't actually want that functionality. I really need a different this inside of it. So I think the key here is not always solving the same problem, but realizing that there's different ways to do it. But to answer your question, I've never seen any performance problem whatsoever that I've encountered where that was the issue I had to change. So great question.
All right. Next up, we have what other options do we have except for ESLint? Like, is there JS hint or something that would like, solve the issues?
Yeah, so that's a great question. So there's a little history. So JS lint was the kind of the first JavaScript linter created by Douglas Crockford, and he was the main maintainer of that project. And it used to say like this linter will hurt your feelings. It was really quite funny because it was very particular, and the community, kind of the JavaScript community at large, wanted to actually add different options, and so there's a little clash of ideas between Crockford and some of the other people. So someone actually forked the repo and called it JS hint instead of JS lint. And what they did is they kept all the rules, they added a couple others, they made some optional, they allowed you to turn off certain things, a little more customizable. So a lot of the community started moving toward that direction with JS hint. And it kind of was the thing to use for a while. I kind of used it for a good while. And then a new tool that Nicholas Zakis created a while back is eslint. And so it takes all of the goodness of JS lint and JS hint, puts them into this thing called eslint, and then makes it customizable. So now you can make all the rules are pluggable. So you can make your own rules as long as you understand an AST parser, an abstract syntax tree. That's what you have to. If you don't know that already, you have to kind of learn that to make the rules. But now they're all pluggable. You can make all the ones you want. They're a little more fine-grained. You could say this is ignore this. This is a warning. This is an error. And also, since it is using AST parser, it's able to solve problems and detect code smells that would have been really, really difficult in the code base that was in JSLint and JS hint. There's some really intelligent rules. I would encourage you just to kind of look through the ESLint rule set. I mean, they're getting bigger every day. ESLint has also moved into the realm of code style as well. So most of the linters are specifically like, is this a bug? Like, am I detecting something that could be a bug or is a bug? Now, code style is more like, I should have a space here, or I should put my bracket here, or I need an empty line here. That's more stylistic. But on a team, especially as you get larger, you do kind of want some consistency to how things are laid out and how things look. And so ESLint will do both. Like it'll do the actual hardcore linting and it'll do the style checking. Whereas there has been like a side project called JSCS that many have used on the side for style checking, but the two teams are merging now. So ESLint was doing some of the style checking, but now the two teams are merging, so it will eventually support even more rules. So ESLint is kind of the way to go these days. It's a very active project. It's pretty much what I would encourage you to use if you'd use anything, and you could integrate it with all the major IDEs, and also you could integrate it with Gulp, Grunt, npm scripts, or whatever build system that you use. And so it's kind of the go-to one that I use these days. Great question.
That was some really interesting bit of trivia that you shared with us. So before we move ahead to the next question, I'd just like to tell all our listeners that the slides will be available to you. I mean, the link to the slides will be available to you in your mailboxes within the next day. And what they do want to ask you is that will the slides also be available for download?
So that's a good question. These are on the web. It's a web project. It's a web application. So it's not easily downloaded. I've tried to convert it to a PDF, but it doesn't convert very well, just with all the various animations, and it's all in HTML and JavaScript, the whole presentation. So unfortunately, you can't download it easily. But it's up on the web, so you're welcome to browse it yourself.
All right. So for all our listeners, you will be having access to the presentation whenever you want, and you will also be getting a video to this entire presentation, so you can look it up at your convenience. Now, up to the next question. In the ES6 class, while writing the DOM event for React code, We do not have access to this object. What can be the reason behind this?
So he said using React, using a class, he cannot get, what was the part for that?
So in ES6 class, while writing a DOM event for React code, we do not have access to this object. What can be the reason behind this?
Yeah, for that particular case, I'd probably need to see the example. If you do use ES6 classes versus using the create class kind of the old way would kind of auto-bind the events and actually wire up this implicit parameter for you. If you use the class syntax, you have to manually say bind when you're, kind of like I showed, when you're wiring that up. If whoever that is could reach out to me, I could send a resource of the difference. And having to do that, it is quite annoying. And if you don't know the difference, it can bite you. It usually does immediately, especially when you're switching from create class to using the class actually keyword. There are ways to get around it. There's another project that will auto-bind all the events for you, so you don't have to manually do them. I don't have those links handy, but yes, that is one of the main differences when you switch from create class to actually using the class syntax.
All right. Next up, the question is, could you go back to the CodeSmells where you were talking about nesting and just go through that bit once again?
The nesting one, so there's two. This one had the deep nesting here. Is that the one you're talking about, or is it the one where I had the repetitive code where it was passing data in? Oh, the repetitive, okay. Yeah, so this one, I imagine, but this is probably not the problem that he was talking about. So this is a solution to that. So I start with the data on the innermost one. This particular function returns kind of the new data that's manipulated, which is now the input of the wrapper function. And then that data gets returned, which is now the input of its wrapper function, which returns the new data, which is the input of the other one. And this gets a little cumbersome, and you definitely don't want to keep doing this because your code will get deeper and deeper and deeper. So the reason I mentioned, so then there's like, hey, we should stick this in an array and kind of loop over the functions. And so that way, so in this, and again, I preferred not the for each, but, and we'll take a look at what the reduce one does. And that might be his question about the reduce because it's a little more complicated. But essentially, I'm taking the data. The first function will be the first item here. So that's what the first func will be. I will invoke that func, passing in the data. It gets the data, massages it, returns it. And then the next loop happens. So now func will be append submission data. Now I'll invoke that func with the data. It gets returned. The next func will be the third one. Then I'll pass the data into that one, and you keep going. Now the reason I don't like this is the code inside of here has to know about something outside of itself. It has to know about this piece of data, which is probably created somewhere way up above. So if you use the reduce, it keeps everything contained to itself. So this particular function right here doesn't know anything outside of itself. It just knows I'm getting a function. I got this, some kind of a memory object. I'm going to pass it in, and then I'm going to return that memory object, which will be the input of the next function. So the way this one works is reduce. Here's the data that I want to start with, which maybe is an empty object. The empty object will get shoved into the first iteration. So this will be an empty object. This func will be the first one. So now I'm passing an empty object into the first function. I'm returning the output, which will now be, the output will now be the memo of the next function. So the func will be the second one. Memo will be the result of the previous result. And I'll pass in the previous result into the second function. The return of that will be the memo for the third function. And so, and then at the very end, whatever is returned at the very last item will get returned as the result here. So the reason I really like this solution is because this particular function knows nothing outside of itself. It's always past what it's needing, so it's very contained. There's nothing bleeding in or out of it. And this last one just happens to be just a nice helper method that I found on Lodash or underscore. That's a different topic for another time, but I prefer Lodash. If you're interested, we could talk about why. But it's faster, it's more modular. But this one, actually, you just pass each argument, the functions that you want to run. You pass it the data, and it handles passing it in and out of each one for you. I'm not sure which one he actually decided on using, but we definitely went through all 4 scenarios, and it was more of a good learning process. Again, like the answer shouldn't always be the same every time. You should know different ways to solve problems and kind of look at the situation that you're trying to solve and figure out what's best for that particular time. Hopefully that answered that problem.
Thank you for patiently going over that bit again. I'm sure that was really helpful for our listeners. And so it looks like we've come to the end of today's session, and that's all the questions that we have. If our listeners have any more questions, please send them to us at webinars@srijan.net, and we will take them up with Elijah and get your questions answered. And so that's it for today, and thank you all our audience for being such patient listeners, and most importantly, thank you Elijah for taking us through the session, and it was a really helpful session, and I'm sure all of our listeners would be ready to use a lot of these tips whenever they're writing JS code next. So with that, I would like to bid adieu for today, and just to remind you, you will be receiving the session slides and the videos in your mailbox very soon, and also along with information about our next webinar. So with that, it's over and out from my side. Thank you, our listeners, and thank you, Elijah, for coming on today.
Thank you for having me. Have a good day.